In this video, we're going to talk about another problem where we'll have to find the volume of the solid of revolution based on the given conditions. So, in this problem, we're asked to find the volume of the solid resulting from revolving the region bounded by the curves y is equal to 4 minus x squared and y is equal to 1 from x equals 0 to x is equal to square root of 3 about the y-axis. Okay, so I'm just going to draw this figure, okay, and you should do the same. Whenever you're asked to find the volume of the solid of revolution, always draw the function given in the xy plane. Okay, so from x is equal to 0 to x is equal to radical 3, right? So let's see. So 1, 2, 3. Okay, bounded by the curves 4 minus x squared and y is equal to 1. Okay, so 4 minus x squared. So when x is equal to 0, y is equal to 4. Right, so we're going to have this part. And y is equal to 1. So when x is equal to 1, now what is square root of 3? Square root of 3 is going to be less than 2, right? So, well, let's see. When x is equal to 1, y is equal to 3. Okay. When x is equal to 2, but we have to go less than 2, right? We have to check the square root of 3 in here. So we'll have square root of 3 squared is 3, right? So 4 minus 3 is 1, right? So square root of 3 is going to be 1 here. Okay. Now I'm just going to write down what this x is. X is equal to square root of 3. Okay. Write it a little clearer. Okay, so x is equal to square root of 3, this line, right? So now we have to revolve this region, right? Because this is y is equal to 1, right? And this is y is equal to 4 minus x squared, right? The equation. So we have to revolve this region about the y-axis, right? So like this. Let me write it a little better like this. Oh. Like that, right? So you know how you can revolve it. So now, here's the key feature. Here's the key point here. The key point here is that whatever you're revolving, whatever the axis you're revolving around, will be the variable that you will be integrating over, right? So in this case, the y-axis is the axis of revolution. So you know for sure that you will be integrating this region over the y, right? And not the x. Okay? And I'm going to explain why. Because notice that the radius in this case, so I'm just going to draw it like this. Right, so this is going to be your, so this is going to be the radius. Okay, and the radius will be the x in terms of y, right? Radius will be r in terms, so I'm going to say x in terms of y. So what that means that the function that we're given, y is equal to 4 minus x squared, must be solved for x so that x is expressed in terms of y. Right? So let's try it. So we have y is equal to 4 minus x squared. So x squared is equal to 4 minus y. So x in this case, since x is positive, we're going to be having 4 minus y. Okay? And the region over which you will be integrating, so limits of integration will be y is equal to 1 to y is equal to 4. Okay? And like I said before, you are integrating over the y because y-axis is the axis of revolution for this problem. Okay? So now, let's integrate that, right? So you know that each slice basically is a cylindrical slice, right? So radius of each slice is going to be the function, which is going to be x. X is equal to 4 minus y. I should erase that. I'm sorry, it's not the best here. So the radius of each slice, that's better, right? is equal to r is equal to x is equal to 4 minus y, square root of 4 minus y. Okay, so the height of each slice is going to be h or dy, the thickness, right? So if let's say this was the circular slice, the cylindrical slice here, this part would be delta y, right? The thickness, the height. It's really small. No. Okay, well, I'm just gonna write it like this. Just gonna indicate it like that, and yeah, maybe that's better. Like that. So you can see it's a cylindrical slice. So this height will be the delta y. Okay? And that will be the radius. This will be the radius, which is the functional value 4 minus y inside the square root, right? So now we're ready to implement this formula, and we're going to integrate from 1 to 4 for the y, right? So the volume of this solid of revolution will be from 1 to 4, and we're integrating over the y, right? So the limits of integration are in terms of y, right? They're the y limits of integration. So we're going to get, so let's see, pi, and r is equal to square root of 4 minus y. And we're squaring that because pi r squared h, right? The volume is pi r squared h, right? So, and then the dy, because that's the height. And we're integrating from 1 to 4, so it's going to be pi. I'm going to take pi out from 1 to 4. Pi times 4 minus y, because squaring the square root gives you whatever's inside, dy. And that is equal to, oh, did I write pi twice? Okay, I took the pi out already. Okay, so now we're going to have pi over 2. Wait, no. Just pi, so just pi for y, right, from 1 to 4, minus 1/2 y squared from 1 to 4, right, using the power rule of the antiderivative. Okay, so that gives us pi multiplied by 4 times 4 minus 1. So in the y we have 4 minus 1. I should keep the pi. Minus 1/2, and then 4 squared is 16, minus 1 squared is 1, right? So now let's see what we're going to get. So we get 12 minus 15 over 2. Okay, so that gives us, let's see, 24 over 2 minus 15 over 2 is 9 pi over 2. Yeah, that's precisely right, 9 pi over 2. Okay, so this is the volume of the solid of revolution for this problem. So I hope this tutorial was useful. Please subscribe and I'll see you in my next video.